He's a professor at Harvard that believes it might be an alien probe.
Considerable size. Across the world, social media has been awash.
And he was talking about the odds of this thing being in the trajectory that it is, entering into our solar system in a direct path with Earth.
In his January 2021 interview with Harvard astrophysicist Avi Loeb, Joe Rogan pressed Loeb to explain why the interstellar object Oumuamua,
Harvard scientist who believes he has seen proof of alien life before, and he suspects this object may not actually be a comet. WBZ's Courtney Cole spoke with him today. Courtney.
first observed in October 2017, might not be just a natural rock, but potentially a technosignature, or an artifact of alien technology. What Loeb said next shook the online community. He even laid out his arguments in his book Extraterrestrial, the first sign of intelligent life beyond Earth. So, did Loeb and Joe Rogan tell us that aliens are real? Well, today, we'll unveil the truth. Let's get started. Joe Rogan, Avi Loeb, and explosive revelations. In mid-January 2021, one of the most discussed episodes of the Joe Rogan Experience podcast brought Harvard astrophysicist Avi Loeb on the hot seat for a 3-hour conversation. The episode, listed as number 1596 and released on January 16, 2021, gave Loeb a platform to discuss his provocative interpretation of the interstellar object Oumuamua, which had been detected in 2017 by the Pan-STARRS 1 telescope in Hawaii. Rogan asked questions that gave Loeb room to elaborate on his arguments, while occasionally playing the part of the curious layman intrigued by the possibility of alien technology. Oumuamua itself had stirred intense scientific debate since its discovery on October 19, 2017. With an unmistakably hyperbolic trajectory, astronomers quickly concluded that the object originated beyond the solar system, making it the first interstellar visitor ever observed. Measuring roughly between 100 and 400 meters in length, it defied easy classification. Telescopic data suggested an elongated or possibly pancake-like shape and a reddish surface consistent with organic-rich ices. More puzzling was its behavior. Oumuamua accelerated slightly as it passed through the inner solar system, an effect not fully explained by gravity alone. Unlike comets, Oumuamua showed no coma, no tail, and no obvious emissions. So what was it? Avi Loeb believed, and still does, that he knew exactly what this object was: an alien probe, or a relic of extraterrestrial technology. Loeb, who had served as chair of Harvard's astronomy department from 2011 to 2020 and published extensively in theoretical astrophysics, began advancing his hypothesis in late 2017 and 2018. Together with Shmuel Bialy of the Harvard-Smithsonian Center for Astrophysics, he published a paper proposing that Oumuamua's acceleration might be explained if it were a thin sheet, only a fraction of a millimeter thick, propelled by solar radiation pressure. In other words, the object might be a form of light sail. Humanity has only recently begun to experiment with this technology through projects like the Planetary Society's Light Sail 2, which successfully demonstrated controlled solar sailing in 2019. For Loeb, the coincidence of Oumuamua's peculiar shape, unexplained acceleration, and lack of outgassing combined into a case that at least merited serious consideration of an artificial origin. Joe Rogan, whose podcast by 2021 was reaching an audience of tens of millions worldwide through Spotify and YouTube, proved to be a critical amplifier. So, could Oumuamua have been a scout sent by another civilization? And why would mainstream science be reluctant to admit such a possibility? By early 2021, Loeb was also releasing his book Extraterrestrial, the first sign of intelligent life beyond Earth, published by Houghton Mifflin Harcourt. The book became a bestseller and further popularized his thesis. Loeb gave numerous interviews across outlets ranging from the New York Times to Scientific American, repeating his call that science should not dismiss extraordinary explanations without investigating them. Not content to stop with theory and outreach, Loeb launched the Galileo Project in July 2021. This initiative, headquartered at Harvard, set out to establish a systematic, instrument-based approach to searching for evidence of extraterrestrial technological artifacts, whether in the form of interstellar objects like Oumuamua or unidentified aerial phenomena within Earth's atmosphere. The Galileo Project began building observatories equipped with telescopes, cameras, and AI-driven analysis systems designed to capture high-quality data on anomalous objects. Loeb emphasized that only empirical evidence could move the debate forward. He frequently contrasted this approach with what he saw as the complacency of much of the scientific establishment, which preferred to default to natural explanations without sufficient curiosity. Yet Loeb's positions generated substantial pushback from his peers. While many astronomers acknowledged Oumuamua's anomalies, the majority favored natural explanations. By 2023, a team of researchers published a paper in Nature suggesting that Oumuamua's acceleration could be explained by the release of molecular hydrogen from ice within its body. This hydrogen outgassing model, they argued, would not produce a visible coma, but could still generate the observed push. Other scientists had earlier proposed that Oumuamua might be a fragment of nitrogen ice, similar to Pluto's surface composition, or a porous, fluffy aggregate with unusual reflective properties. Loeb refused to retreat in the face of criticism. He countered that many of the proposed natural explanations required highly unusual circumstances themselves, making them no less extraordinary than his own hypothesis. Furthermore, he argued that dismissing the possibility of an artificial origin outright amounted to a failure of imagination. To Loeb, the history of science, from Copernicus displacing Earth from the center of the universe to the discovery of exoplanets in the 1990s, was a sequence of paradigm shifts born from confronting anomalies. Beyond Oumuamua, Loeb has made additional claims that attracted both intrigue and skepticism. In 2022, he argued that a meteor that struck near Papua New Guinea in 2014, known in NASA's CNEOS database as CNEOS-2014-0-1-0-8, might have been of interstellar origin. He later organized expeditions to search for fragments on the ocean floor. Here, he reported finding materials with unusual properties. But before we go any further, let's get some context first. Oumuamua, what we know and what we don't know yet. When astronomers using the Pan-STARRS 1 telescope in Hawaii detected a faint, fast-moving object on October 19, 2017, they quickly realized it was unlike anything ever observed before. Calculations showed that the object was following a hyperbolic trajectory, meaning it was not bound to the sun's gravity and had entered the solar system from interstellar space. Designated 1 2017. One and later given the Hawaiian name Oumuamua, meaning a scout or messenger, it became the first known interstellar object ever observed passing through our planetary system. Its arrival offered scientists a unique chance to study material formed around another star, but it also sparked one of the most intense debates in modern astronomy. What exactly was this visitor, and why did it behave so strangely? From the earliest observations, Oumuamua defied easy classification. Astronomers estimated that it was at least several hundred meters in length, but its brightness variation suggested an elongated or possibly flattened shape, with a length-to-width ratio as high as 6:1 or even more extreme. Some models allowed for a pancake-like geometry, while others supported a cigar-shaped object. But in either case, its proportions were far more extreme than typical asteroids or comets seen in the solar system. Spectral analysis revealed a reddish hue, consistent with organic-rich surfaces exposed to cosmic radiation over millions of years. The object also rotated in a tumbling, non-principal axis motion. One of the most puzzling aspects of Oumuamua was its trajectory. As it left the inner solar system, astronomers noticed that it was moving slightly faster than expected under the influence of gravity alone. This non-gravitational acceleration was small, on the order of 0.1 millimeters per second squared, but significant enough to demand explanation. For comets, such accelerations are usually attributed to outgassing, jets of water vapor, or carbon dioxide sublimation. Yet no cometary coma, tail, or gas signatures were detected from Oumuamua. The Spitzer Space Telescope and other instruments exhausted all efforts and yet failed to find anything. Given the mystery, some teams turned to radio telescopes to listen for possible artificial signals. The Breakthrough Listen Project, an initiative dedicated to searching for extraterrestrial intelligence, directed the Green Bank Telescope in West Virginia toward Oumuamua in December 2017. Over several observation windows, the telescope scanned across a wide frequency range. No artificial radio emissions were detected, placing limits on the possibility that Oumuamua was an active transmitter or probe. However, the null result could not definitively rule out an artificial origin, since a probe might remain silent or use communication methods beyond human detection. In the years following the discovery, researchers proposed a wide array of natural explanations. By 2023, one of the leading models was developed by a team of planetary scientists who suggested that Oumuamua's acceleration could be explained by the release of molecular hydrogen. According to their work, published in Nature and other peer-reviewed outlets, energetic radiation over millions of years could cause radiolysis of water ice within an interstellar icy body, producing trapped hydrogen gas. As Oumuamua warmed during its passage near the Sun, the release of hydrogen gas could provide sufficient thrust to account for the measured acceleration, without producing the visible coma associated with typical water-driven cometary activity. Other natural models were also explored. One hypothesis proposed that Oumuamua was a fragment of solid nitrogen ice, chipped away from the surface of a Pluto-like exoplanet during a collision and sent drifting into interstellar space. Nitrogen ice would sublimate under solar heating, generating thrust while leaving little detectable debris. Another model suggested an extremely porous, fluffy, comet-like aggregate with low density, allowing radiation pressure to play a more significant role. However, Avi Loeb of Harvard University was not convinced. He believed that this interstellar visitor was of an artificial origin. In a 2018 paper co-authored with postdoctoral researcher Shmuel Bialy, Loeb argued that the anomalous acceleration could be explained if Oumuamua were a thin sheet, perhaps less than a millimeter thick, propelled by solar radiation pressure, similar to the concept of a light sail. Loeb expanded on this idea in his 2021 book, Extraterrestrial: The First Sign of Intelligent Life Beyond Earth. Loeb believes that Oumuamua was a fragment of alien technology, such as debris from a probe or a piece of discarded equipment. The technosignature hypothesis was provocative but controversial. Most astronomers considered it less likely than natural explanations, pointing to the absence of corroborating evidence, the limited observation window, and the plausibility of physical processes like hydrogen outgassing. However, observations of Oumuamua were possible for only about 11 days, with sufficient clarity before it became too faint for most telescopes. No spacecraft was in position to intercept it, and by the time its interstellar origin was recognized, it was already on its way out of the solar system. As a result, much of the data comes from limited photometric and spectroscopic measurements, leaving significant room for interpretation. Without direct sampling or imaging, many of the finer details about its structure, composition, and exact mechanism of acceleration remain beyond reach. The mystery of Oumuamua has broader implications for planetary science and the search for life. Its discovery demonstrated that interstellar objects do visit our solar system, and that new surveys can catch them in action. In 2019, a second interstellar object, 2E Borisov, was discovered by amateur astronomer Gennady Borisov in Crimea. Unlike Oumuamua, Borisov behaved much more like a traditional comet, complete with a coma and tail, providing a useful contrast. And now we have a third one, 3I Atlas. Imagine never coming across such an object for all of human history, and then spotting 3 within a decade. Looking ahead, the Vera C. Rubin Observatory, scheduled to begin full operations in the mid-2020s, is expected to revolutionize this field. With its wide field survey capabilities, it should detect many more interstellar objects each year, allowing scientists to build statistical samples rather than relying on singular anomalies. Future missions have also been proposed to launch rapid response spacecraft capable of intercepting and studying interstellar visitors up close, potentially within weeks of their discovery. Such missions could provide the definitive evidence needed to resolve debates like those surrounding Oumuamua. But what if Loeb is correct about Oumuamua? Are aliens watching us? Well, believe it or not, the idea has been entertained by mainstream science. Fermi paradox and the zoo hypothesis. In 1950, physicist Enrico Fermi, while having lunch with colleagues at the Los Alamos National Laboratory, posed a deceptively simple question: where is everybody? His remark crystallized what would later be formalized as the Fermi paradox. This is the apparent contradiction between the high probability of extraterrestrial civilizations in the galaxy and the complete lack of confirmed evidence for their existence. Given the billions of stars in the Milky Way, many of them older than the Sun and hosting planets in their habitable zones, it seems statistically likely that intelligent life should have arisen elsewhere. Yet, despite decades of astronomical surveys and SETE, or search for extraterrestrial intelligence efforts, humanity has no verifiable signals, artifacts, or encounters to show. The paradox rests on numbers as much as it does on absence. The Drake equation, formulated by Frank Drake in 1961, estimates the number of communicative civilizations in our galaxy by multiplying together factors such as the rate of star formation, the fraction of stars with planets, the number of habitable planets per star, the likelihood of life developing, and the probability of intelligence and technology arising. While the values for many of these terms remain uncertain, modern exoplanet discoveries have significantly strengthened the case for habitability. Data from NASA's Kepler Space Telescope, which operated from 2009 to 2018, revealed that roughly 20 to 25% of Sun-like stars may host Earth-sized planets in the habitable zone. With over 100 billion stars in the Milky Way, that could translate into tens of billions of potentially habitable worlds. This statistical weight only sharpens Fermi's question: if life is common, why is the galaxy so silent? One of the more intriguing proposed solutions to this question is the zoo hypothesis. First articulated by MIT radio astronomer John A. Ball in 1973, the idea suggests that extraterrestrial civilizations might deliberately avoid contact with humanity, much like zookeepers avoid disturbing animals in a preserve. According to this view, advanced civilizations could be aware of Earth and our species, but may have chosen a policy of non-interference until we reach a certain threshold of development. To them, Earth could be a kind of protected experiment, a natural habitat to observe without tampering, preserving cultural or evolutionary integrity. Changes one's perspective on objects like Oumuamua, doesn't it? Well, at least it's something to think about. Aliens may already be here, and we might not know it. Just as animals in a reserve may not recognize the fences, cameras, or caretakers surrounding them, humans may lack the awareness or capability to perceive the surveillance of a more advanced species. Alien observers might have cloaked their activities, using technology beyond our comprehension to remain hidden. They could, for instance, position passive sensors in the solar system, deploy disguised probes, or monitor from afar using methods that do not emit detectable signals. Some have proposed the idea of surveillance probes, akin to the fictional von Neumann probes, which are self-replicating robotic scouts that could spread through the galaxy over millions of years. If such devices exist, they might masquerade as asteroids, comets, or space debris, blending seamlessly into the environment while quietly relaying information back to their creators. Others have suggested advanced civilizations might use stealth technologies far superior to our radar or optical detection capabilities. ensuring that their presence remains invisible until they choose otherwise. While these concepts remain unproven, well, at least for now, they cannot be dismissed entirely in the absence of direct evidence. Coming back to the Fermi paradox, another hypothetical solution is the Great Filter, a concept introduced by economist Robin Hanson in the 1990s. The Great Filter suggests that somewhere along the pathway from prebiotic chemistry to galaxy-spanning civilization, there lies a bottleneck so improbable or destructive that most, if not all, life fails to cross it. This filter could be behind us, making the emergence of intelligent life exceedingly rare, or ahead of us, implying that most civilizations self-destruct through war, environmental collapse, or technological mismanagement before achieving interstellar communication. Then there is the dark forest hypothesis, popularized in the science fiction novels of Chinese author Liu Cixin. In this framing, the universe is like a dark forest where every civilization is a hunter, armed but fearful, aware that any signal could betray its location to a potentially hostile competitor. If this model is correct, civilizations may indeed exist, but actively avoid contact. Humanity's own radio leakage and early attempts at interstellar messaging could, under this hypothesis, be dangerous broadcasts into a hostile wilderness. Distance and timescale provide another partial explanation. Even if civilizations are common, the galaxy is immense, 100,000 light-years across. Civilizations may rise and fall across spans of millions of years, their signals faint and dispersed, rarely overlapping with ours in both time and space. It may be that intelligent species do send signals, but they are rare, intermittent, or not directed toward us. Alternatively, they may communicate using methods we cannot yet recognize, such as laser pulses, neutrino beams, or quantum phenomena, rather than conventional radio. To us, this would appear as silence, though to them it might be a bustling conversation. Avi Loeb thus insists that we should build instruments and search systematically for technological artifacts. His founding of the Galileo Project in 2021 reflects this philosophy: to move beyond speculation and acquire direct, high-quality observations of unidentified aerial phenomena and interstellar visitors. So, what do we know so far? The debate over Oumuamua reflects the tension between scientific caution and openness to bold ideas. Peer-reviewed studies in Nature and the Astrophysical Journal favor natural explanations, such as hydrogen outgassing or nitrogen ice fragments, while Avi Loeb's artificial light sail hypothesis has drawn wide media attention, notably in The New Yorker. Most astronomers insist on extraordinary evidence before accepting extraordinary claims. Yet Loeb's perspective has energized new approaches to technosignature searches. The zoo hypothesis extends this debate by suggesting extraterrestrials might deliberately avoid contact, silently observing humanity like animals in a preserve. Although untestable with current tools and lacking direct evidence, it highlights the limits of human perspective. Ultimately, the Fermi paradox remains unresolved, not from a lack of ideas, but from a lack of data. Future observatories like the Vera C. Rubin Observatory and ongoing SETI searches may finally clarify whether the cosmic silence is genuine or only apparent. So, all we know is that we know too little. Well, that's it for now. Thanks for watching. Did you like this video? If you did, please consider liking, dropping a comment, and hitting the subscribe button so that you don't miss out on our new uploads. Also, don't miss this video you see on your screen right now. It's truly unbelievable.